All right, so welcome back to the Civil FE exam review. In this video, we're going to be looking at force acceleration. Now, this is a continuation of the dynamics portion of the review. So I think there's 4 different sections that are covered as far as in dynamics, and this is one of them. And so I want to show you, I guess, where we're at in our review so that you're not confused. So in the handbook, we know that we are here, right? We're going through force acceleration. If you didn't check out or haven't gone through mass moments of inertia or kinematics, make sure you do that. Those are very important topics as well. And we're also going to be covering work, energy, and power. So, but got some practice problems for y'all. So let's go ahead and get into them. So, number 1 says a 5 kilogram box experiences a net force of 15 newtons. Calculate the acceleration of the box. Unit should be in meters per second squared. So given you got a net force 15 newtons. All right, they give us the mass of the box, not the weight of the box, but they give us the mass of the box, which is 5 kilograms. All right, so weight and mass are different. This is a mass. Okay. Calculate, we're trying to find the acceleration. So are there any formulas needed? In this case, yes, if you don't already know. So we're trying to find the acceleration. They give us the net force. So maybe a good starting point to find this, because let's try dynamics. With respect, and you want to find, basically what we're looking for is we have mass and we have force, and we're solving for acceleration. So how do those all tie in together? All right, so we can see here sum of the forces is equal to mass times acceleration when motion exists only in a single direction without loss of generality. It may be assumed to the x direction, a of x is equal to f of x over m. Okay, so we can for sure say the sum of the forces equals mass times acceleration. So the net force, just the sum of the forces, is equal to mass times acceleration. Okay, so I got 15 newtons for my mass, and we have 5 kilograms for, or I got 15 newtons for my force, I'm sorry, 5 kilograms for my mass, and then A is what we're trying to solve for, which is acceleration. Okay, and if you didn't know this stuff, the sum of the forces equals the sum of the applied forces acting on a particle. M is equals to the mass of the particle. So anytime, typically, most of the time, the handbook is going to give us guidance on what some of these things are, but as long as you're doing practice, you'll know where to go. Okay, so 15 newtons divided by 5 kg is equal to 3 meters per second squared. Okay, so anytime you do newtons over kilograms, right? I'll show you how this comes out to be 3 meters per second squared, because I'm sure you're like, okay, that doesn't make sense. So if we go to unit conversions in the handbook, this is all in the handbook. So nothing, most of the things that I do, if it's not in the handbook, I probably won't know it. All right. Okay. So I know that 1 Newton is equal to 1 kilogram. Y'all seeing where I'm at? Maybe, maybe not. Let's try to slide this over. All right. So I know that 1 Newton is equal to 1 kilogram times a meter per second squared. So if we want to just change this around, right, and say, just convert our newtons to kilograms times meters per second squared. So I might say 15 newtons. And I know that, just do our unit conversions here. 1 Newton is equal to 1 kg per, sorry, kg times meters per second squared. Okay. So these cancel, these units, so it just equals 15 kg meters per second squared. Okay. So now if I took that and I said 15 kg meters per second squared, and I divided all that by my 3 meters per second squared, right? Then I end up getting 5 kilograms for my box, or vice versa, because that's not what I was intentionally meaning to do, but that's how my units came out. So if I do 15 kilograms times the meters per second squared, and I divide it by my 5 kilogram box, all right, those units will cancel, and I'll be left with my 3 meters per second squared. So this is a quick, you can, skip steps if you know what you're doing, but you need to know that 1 Newton does equal 1 kilogram times meters per second squared. All right, went all around the world for that one. Don't know if that was necessary, but let me know if this was helpful. All right, so B for number 1. Let's look at 2. If the force acting on an object is doubled while keeping the mass constant, how does Newton's second law predict the change in acceleration? So we're given, let's not deal with red anymore. I think that red is popping out at me and I don't like that. Right, so the information that I'm given is there is a change in acceleration. All right, there's, or sorry, we are given on the object. Okay, force is doubled. I'm sorry. So we got force is doubled. We also have that mass stays the same. How does Newton's law predict? All right, so what are the formulas that we need, right? So going back, we're dealing with force, mass, and acceleration. So formulas definitely needed is force is equal to mass times acceleration. So we can do this ourselves, right? All right. If force is 1 and mass is 1, that means acceleration needs to be 1. All right, but if we double the force and we say 2 is equal to, and we leave mass to stay the same as 1, what happens to A? Well, now A equals 2. So we double our force, seems like our acceleration is double if the mass stays the same. So does the acceleration remain the same? No. Is the acceleration halved? No. Acceleration is doubled. Yes. Quadrupled, I don't know how that would be the case. So you'll notice that anytime you are going through this stuff, just do the simple math to make it make sense in your head. So maybe the way that I did it doesn't make sense, but go through, and if they say the force is doubled, put it in the equation, double it, and see what happens. If they say that the mass stays the same, keep the mass the same, and then isolate your variables that you need. So this is more conceptual, but it's coming from a formula. So still math is involved, which makes it still very like definite. You don't have to guess on something like this. Alrighty. Number 3. This one says a force of 20 newtons is applied to a 5 kilogram object on a frictionless surface. Calculate the acceleration of the object. Okay. For some reason, I want to draw this out. I'm going to use blue. That is 5 kg. Let's call this a kickball. And, we're applying some type of force, 20 newtons to the 5. So how do we calculate the acceleration? Well, acceleration, force. So we're given force. We're also given the mass. and we're trying to find acceleration. So again, we know that we need to use F is equal to mass times acceleration. If we have force, we have mass, we just have to solve for acceleration. So, and our units need to be in meters per second squared key. So answer is going to be, so I know force is 20 newtons, and I know that my mass, right? My mass is going to be 5 kg, and I'm left with A. A is equal to 4 meters per second squared, or B. Ready? Good stuff, good stuff. So this concludes the force acceleration portion of this review. The last section for dynamics is going to be work, energy, and power. And we'll look at that in the next video.